Hi everyone. So this week I built an agent with this MPDA architecture. MPDA stands for Memory, Perception, Decision, and Action. This agent has like clear separation of roles and boundaries. Right. A simple tool calling agent can't solve a complex problem having multiple objectives or user queries having multiple objectives. So that's why we have this architecture where there are four separate components and we have clear separation of roles and boundaries between them. The boundaries are established with Pydantic contracts. Right. So I'll go through all these four layers one by one. First, let us look at the MCP server that we have here. So this is a remote MCP server, or we can also use it as a local MCP server with a STDIO transport. So it has like a few tools. Let me go through all these tools one by one. Yeah, so we have web search tool, which uses Tably or DuckDuckGo to do a web search on a query. Then we have this fetch URL tool. It uses the scroll for AI to convert a web page into a markdown, which can be consumed by the LLM. Third is get time. If you want to know the time, current time, or some offset time, then we can use this tool. Currency convert to convert currency between different amounts. And then we have this read file, which reads a file from a disk local path, and then list the directory in that path. Create file creates a file to a path and writes its content, writes certain string content to it. Then we have this update file, which will overwrite a file, and edit file, which will edit the content in a file. So all of this file stuff works in a sandbox. Alright, so let's jump back to the agent loop. So first we have this mm, client to connect to the MCP server. So it's a streamable HTTP client. So this basically can be used to connect to any remote MCP server. Um, since we have that crawl for AI, so that does not work with STDIO, so that's why I moved to this streamable HTTP transport for the MCP server. Then we have this load tools here. Okay, so this is the agent loop. So first we use something called LLM Gateway. I'll just show that. So LLM Gateway, these are some freely hosted models. So Gemini has some free tier. Similarly, NVIDIA, Grok, Cerebras, OpenRouter, GitHub, and Olama. So all of these have some free tiers. Olama, we can run it locally. Any models like Gamma 4. Right. So I'm using this to mm, basically, if a certain provider request gets over, then we can switch to another, or if some error occurs in certain provider, then we can switch to any other provider, so that our agent loop does not break. Right. So this function like ensures that the LLM gateway is up and running, Okay, then we generate a run ID, and this tracer is a for logging the traces, agent traces. We have this tracer. Okay, then we have the conversation history. So initially we set it to empty dictionary. Prior goals set it to empty dictionary. Okay, then we have the four services. Memory service, perception, decision, and another one artifact service. So I'll go through this one by one. So first is the perception service. So perception service is, you can think of it as a planner for your task. So whenever a user query is received, we want to break the query into certain objectives or goals. So the goals has to be bounded goals, and these goals can be passed to the decision, and the decision takes the uh, decides, like, based on the goals it has received, it decides which tools to call. It also the perception also can attach uh, any attachments or files to files ID to the decision, and decision can read those to come to a final answer for that goal, for that particular goal. So uh, once all the goals are received, the perception can provide the final answer. One more job of the perception is to, like, uh, create the goals, and then it can set the progress of the goals. Like once the goal is completed, it will set it to done. Right. So this is the work of perception. Similarly, decision, like I said, it decides which tool to call. Right. So it can be like a tool calling agent. Right. So then we have this action service. So action service uh, does the tool calling part. So that tools that needs to be called and its parameter are passed to the action service, and it calls the tool and then returns the result. One more thing, when the if the result is large, right, we can't persist it in the conversation history. We don't want to bloat our context. So what we do is, we if it exceeds 4 kilobytes, we store it in a file and record its ID. Basically create an ID and record it. Uh, we also record its metadata, so that is called an artifact. Right. So I'll just go back to the agent loop since we have an idea of all the services now. So first we get all the tools. Okay. I think I missed something. So here we have the history, and then we have the prior goals, which is empty now. Then we have the memory dot remember. So memory, actually, if you want to store some durable items or facts, preferences, tool results, those things can be stored in the memory. So memory dot remember, every time a query comes, then we classify it into fact, preference, tool call, uh, or scratchpad. Okay, and then we store it in the memory. Right. So this is the agent loop. We have this max iteration, then the logger is there. So first thing is hits. So hits will do a keyword search on the memory. We pass the query, we pass the conversation history, do a keyword search, get the top k. Okay, before moving forward, let me show the schema once. So this is the schema with all the Pydantic contracts. So memory item will have an ID. kind will specify whether it's a fact, preference, tool, outcome, or scratchpad. Then we have the keyword list. Descriptor is a short description of the of that memory item, and then we have the value. Um, Value is basically an important structured items, like for example date, uh, then artifact id if any artifact is there in that memory. So if any file, if you want to bind, then directly we don't bind the file, but we bind its id. Then the source is the file path, run id is the id of the run, agent run, goal id is the id of the goal. Then confidence, when we classify the memory item into these four uh, classes, we also attach a confidence to it. Then the date time when it was created. And then we have this artifact. Artifact can have these five things. Uh, id follows this pattern, art, and then an integer. Then content type, size in bytes, source, the file path of that artifact. Then the descriptor is short description of the artifact. Uh, then for goals we have the id, then a description of the goal. Done, it's a boolean true or false, and then the attachment artifact id. So if any attachment is required for this goal, then we pass its id to it. So the perception attaches this id in the goal. And then we have the observation. So this the output of the perception. Uh, we have the goals list. Then the next goal that decision has to that is needs to pass to the decision, and then the final answer. Uh, then we have the tool call. Tool call will have the name of the tool and then the arguments of the tool. This is the output of the decision. It will either have answer or tool call. I'll just go back to the agent loop. So hits I covered. Then keywords. So hits will return, as I showed in the schema. It will have a memory item. It will contain a keyword list as well as one of the key value pair, so that we are extracting, and this will be fed to the perception and the decision in their prompt. Uh, then we have this perception, and we output of this is an observation object with goals, and then the unfinished goal and final answer. So perception dot observe will call an LLM. So I'll just go there. So first it will build a prompt using the query heads keyword, basically history, and if any prior goal is there. So this is the call to the LLM. So we use that gateway, chat endpoint of that gateway. We pass the prompt. Auto route is perception. So based on this auto route, so since perception is like the main uh, manager of the agent, we can use a heavy model, like a large model like Gemini, so we can pin it to Gemini by providing the provider SG. And then we have the auto route. Auto route would basically, based on the complexity of the query, it will classify which models to use, like a large model or a smaller model. And then you have the response format. We want a JSON format, and we pass the schema of the observation. Okay, and once we receive the response, then we also validate whether it's a proper schema or not. Okay, so the observer will return that. Maybe I'll just show the prompt as well once. Yeah, so first we build the memory hits, we add the keyword and artifact ID present in the memory. Okay, and then we have the history, conversation history. We get the we build this kind of thing in the prompt. We pass this to the prompt basically, the iteration, goal ID, then response type, whether it's a tool call or whether it's the answer from the decision, tool arguments, then the artifact ID. So all of this is from the history. Then if any prior goals are there, then we attach this done to the prior goals if it is completed, right? And if it is not completed, we attach this pending to it. So this is the prompt. We have this memory section, history, prior goals. Uh, then we have proper instructions on um, so how to break down the goals to not mess up the goal order, to mark the finished goals only, and finished goals should not be unmarked again. So these are instruction we have. Then the output format. Okay, then we have some internal self checks and fallback behavior if something fails. Okay, then the response format. Right, so this is the final response. It will return an observe object. So observe object will have goals, next, unfinished, and final answer. So we have some examples of it for the response format. And then finally we have this reminders on what all it needs to self check. So all of this this complete prompt we can validate whether it is passing through um, the prompt check. We have a checklist for the prompt, so we can go to ChatGPT with this prompt evaluation. Uh, this is the prompt for prompt evaluation. So it will evaluate the prompt based on explicit reasoning, then structured output, tool separation, conversation loop, instruction framing, internal search check, reasoning type awareness, and fallbacks. So all of these instructions I have given, then I will pass the the system prompt that I have created. So I'll send this prompt to ChatGPT. So we can see that it passed all of these checks we have. Right, I'll go back to the agent now. So then we check whether all the goals are done and perception has provided a final answer. If the final answer is there, then we log it. It if it is not there, so if it is there, then we log it and break. Right, and suppose okay, then if this condition is not passed, then we set the goal to the next unfinished goal. Okay, and here we attach the artifacts. So if the goal has any attached artifact ID attached by the written by the perception, we attach those attachments bytes, we read it, okay, and then we store it in this list. And this list can be is passed to the decision layer, and in there we in the prompt we pass it. Okay, then out is a uh, decision output object. So it will have either a tool call or final answer. If it is a final answer, then we append the history. Okay, and final answer of the decision, not the final answer of the query. So decision answer basically. Uh, so if all the iterations are done, we exit. Uh, okay, otherwise we continue. We continue to the perception, back to the perception. Okay, and if it is not a final answer, it will be a tool call. So we execute that tool call. We get the tool call output and the artifact ID. Okay, and so this is just for logging the uh, tool call output. And yeah, then we finally record the memory outcome. So the tool call outcome, we record it in the memory. We pass the result text, tool call artifact ID, run ID, goal ID. So all of this is stored in the memory and then passed to the perception and decision in the next iteration. We also append to the history the iteration kind, goal, all of these things, right? And this is outside the loop of that max iteration. So once all the goals are done or max iteration is reached, then we get the final answer, and then we record the final answer. So this final answer we get it from the perception sorry, observation object, which is the final answer.